in this example we are going to be adding some collision detection. The first thing I'm going to do is I'm going to reduce the scale of the character now, because in comparison to the platforms he was quite big in the last example. So LG, that's the instance name, and then we're going to use the property scale X, and that's going to equal 0.5, so that's representative of 50%. And if you do the same in the y-axis, scale Y, then we should get the character scaled. So I'll just test that, and there we go. Substantially smaller than he was previously. So what we're going to need to do, we're going to need to listen to see if the character is colliding with objects, and the way we're going to achieve this is we're going to add some collision points to our character. So if I just go to the library and quickly look at the character, what we've got is one registration point, so that's one point that we can make a collision detection with. However, what we can achieve is that we can add additional points to check. So these are going to be imaginary points based on coordinates, and we will put them on the left hand side and the right hand side to start off with, although eventually we'll have an imaginary point on top as well, and one that bonds with the bottom of the character, so that we know whether he's on the ground or banging his head on a platform or bumping left or right. So bear in mind how big the character is. I'll start off with, he is 186 wide and a height of just short of 300. So we'll be basing this on putting a point in an imaginary position which will be halfway up his body, and one that is to the right by about 50%. And so we're going to do this by approximating the sizes. So half his width would be about 90 pixels, half his height would be about 150. However, in this example, because we've reduced him in scale by 50%, those numbers again will need to be reduced by 50%. So I'm just going to create two further boolean variables, which are true and false variables. One can be left bumping, and that is a boolean which initially will equal false because we don't want him to be bumping on anything to start off with, and right bumping, another boolean, again false, and then we're going to add some points. So I'll have a variable called right bump point, and that's going to be a point. I want a point. So I'll use the keyword new point. In brackets we then give the value x and y for that point. So this will be relative to the bottom of our character. So our character was 186 wide and nearly 300 tall. So half of 186 would be 93, but we'll say 90 for argument's sake. And half that again, based on the fact that we scaled it by 50%, would leave us roughly in the area of 45. And the y coordinate would be half of 300, which is 150, and half that again, so 75. Should roughly give us our right bump point. And when we add that on to our registration point, our x and y value for the character, that should put us roughly in the area. Although rather than adding on the y value, we will actually be taking it away because we're using a registration point at the bottom of the character. So left bump point, similarly a new point, and that is going to be to the other side, so minus 45, to the left, minus 75, and that should give us a point of reference. Okay, so now we're going to level function, and this is where we're going to add the collision shape flag, which will be true. This allows us to check that the movie clips are actually crossing over, because currently without the shape flag it will be based on a rectangular bounding box, and the level takes up the whole of the screen, so therefore they would always be ringing as true. So let's just trace out in a statement here. We'll just say right bump, so that when we test this we will know if we've got our calculations correct. Just got to get our syntax correct first. Yep, an extra bracket there, because we have one for the if statement and one for the hitTestPoint method. That should now be syntactic. So all we need to do now is, there we go, as the object passed through this column, the output window came up with right bump. Okay, so all we would do in that case, instead of tracing our right bump, is we would then set right bumping to be true, and equally we can then just copy and paste that function, and instead of it being right bump point, it will be left bump point in both these cases, and then we would set left bumping to true instead. Once we've done that, after we've added any acceleration or speed, I'm then going to update in case of bumping. So if right bumping we will just put x speed times equals, let's just make it -half, so that it should bounce and slow down at the same time. Let's just see how that works out. There we go. As initially worked. Just got a few things to amend there. So let's just change that to else. Put a couple of else statements in, so that if it's not, that we set right bumping to false again, and equally the same for check there. Let's check that again. And just need to rectify a little mistake there. Okay, so I've actually got right bump in there. So let's change that to left bumping. There should be one more thing to do after this, but we'll just test that. There we go, we have bump, and now all we need to do is make sure that it works correctly. So, as it happens, when we're making the speed reduce, we actually need to check to make sure that the object is still moving in the right direction. So actually looking for if x speed is greater than 0, because it's moving from left to right, then we can do this, and if it's not greater than 0, then it will not bounce in that way, which should stop us from having our character get glued to an object. So there we go, you see it bounces off nicely, and to the left just need to add in our actual response for if left bumping. So if left bumping, and in case of left bumping, instead, because it's moving in the left direction, and so the speed will actually be a negative number in that direction. So we just test that. There we go. Right to left, and that is the basis of our collision detection. It's not perfect, can be broken at this stage, but we'll address that later on in the game. Okay.